Video here is going to explain how to do and manage assignment 2. And I just wanted to get started first by talking about a couple of concepts that are really important. So first of all, if I zoom in here, we can move over here to this integer box. So I want to mention the importance of decimals in Max. It's really important for several reasons. First of all, the biggest reason is that sometimes you need data to be more accurate to the decimal than just a full number, right? A what's called an integer. So an integer, again, is a number that doesn't have any decimal values behind it. A float number is a number that has a percentage of a whole number inside it, like 1.4, 1.7, 2.335, whatever. An integer is 5, 7, 12, 18, those whole numbers, okay? So one thing to notice in Max, right here I have two multiplication objects. The first one you can see is multiply times 2, right? And you can see that after it there is no decimal. The other multiplier here is multiple times 2 decimal, right, or 2 point. And what this does is this tells Max that you want to multiply a float number, okay? Now that doesn't mean that a float number is always being multiplied, but that you want it to recognize the float values in a number when doing multiplication or division or whatever. So you can see when I lock this, if I start putting numbers in here, 10 times 2 is 20, 10 times 2 decimal is also 20, but you can see that the decimal here, it's not really doing anything, right? Because I'm multiplying by a whole number. But if I were to put in here 10.6, you can see that the only number that changed was the float number, right? Because the other multiplier, this one, is ignoring the decimal point because you told it, don't worry about decimals, these are whole numbers only. So you can see if I do this, the integer multiplier is only going to give me whole numbers, and the float one is going to give me the full value. So it can be really important how you multiply things or how you send data. If you want an integer below 1 is the most important thing, right? For instance, if I want to have a value below 1, so we do this kind of thing in Max a lot. If I do this, you can see I can get an integer below 1, right? Like this. But if I were to have a decimal only, I'm going to have either a 1 or a 0, and that's it. I'm never going to get any values below that. And this can be really problematic. It's going to be problematic today on the assignment. So you need to make sure the decimals are honored when they're needed, when they're wanted. So let's get started then on what we've got here. So we're doing two new things today in Max. The first is we're going to make, sorry, let me get the comment, a sequencer. Sequencer. And the sequencer is going to do one thing mostly, play a series of notes and play them in order, play them over and over and over. It's just a way of automating the MIDI keyboard. Instead of playing notes on the MIDI keyboard, we're going to create a short, small sequencer that's going to play notes on the keyboard. The second thing we're going to do is implement a envelope, okay? So as you know right now, Max, when I play a note on the Max synthesizer, it plays constantly. It never stops. It's basically an open hose, right? As long as my notes, I'm unmuted here, I send a note to the keyboard, and then I turn the volume up. Oh, I don't have the digital audio converter running. I'm going to hear that note all the time. It's never going to stop. So in this case, of course, the keyboard is continuously playing because there is no envelope, they're called, to tell it to stop, okay? Now, in terms of sequencers, or in terms of pro audio, we've talked about this before. The envelope is specifically the ADSR, right? It's the attack, decay, sustain, and release of a sound, all right? So we want to create an ADSR so that these sounds fade away basically after they're hit, right? They, like a piano, the way they react on a piano, okay? So let's actually start with the sequencer because it's pretty simple to do, but it does come up with some components. So the first thing is we don't need note in anymore because we're now going to create a sequence. So I'm going to delete that, scoot this down a little bit so I have some more room. And if I connect an integer box to the piano, you can see that if I put some notes in here, it is going to choose specific notes, okay? So what I want to do then is probably send specific note values into this box, all right? And there are quite a few ways of doing this, but we're going to do a pretty simple way. So the first thing is I need to make a metronome, right? So I hit new, N for new, metro, and I'm just going to put 500 in here, okay? Now 500 is the milliseconds again, so that means I'm going to get a bang every 50 milliseconds, or sorry, every half a second, so every 500 milliseconds. I'm also going to attach a toggle to this using the T key, T for toggle, connect it, and now if I make a bang as well, B, it's going to now bang every 500 milliseconds, okay? So obviously connecting this here isn't going to do any good because, you know, the bang doesn't give me a name of any kind. It doesn't give me a number. It's only sending, you know, a bang. So we need to use this to trigger something, okay? And what we're going to do to use it to trigger is the counter, which I've talked about before, all right? The counter is a great object because it counts, okay? That's what its main job is. And it can be used for all kinds of things. I'm using this for many, many reasons, but it's specifically good for creating sequencers. So let's do a number between 1 and 8. So what's going to happen now when I connect the bang to the counter, of course, is that it's going to count from 1 to 8. But the problem is we don't want the note, we want MIDI numbers that are relevant for us, right? 1 through 8 is not relevant MIDI numbers. Those are very low notes on the MIDI piano. We probably want to start around 60. So we could do something like this. Like if I did plus 60, then my first note, or if I did plus 59, I will get a series between 60 now and 68. And you can see, or 67, right? Sorry. It's now playing a chromatic scale starting on number 60 and going up to 68, or 7. But this isn't very musical. I'd like to play a chord maybe, or several chords, all right? So let's find a way to make chords instead. So another incredibly useful tool in Max is something called select, okay? And there are several, if I write select, this is the same object as this one, which is just SCL. And what this does is it allows me to basically parse out this data in a specific way. So let me show you. 1, 2, 3, 4, 5, 6, 7, 8. So what's going to happen now is that if the number coming out of the counter is a 1, in fact, let me just grab one of these and stick it here, then it's going to, so let me scoot this up. Sorry, give it a little room here. So if I mouse over the first inlet, you can see outlet, sorry, it says select bang if input matches 1. And then the next one, bang if input matches 2. Bang if input matches 3. So what's happening, of course, is when these numbers come through here, they are parsing the bangs out to these each individual outlets, okay? And what I can do with that then is this. Well, let's just do that to show you the bangs. I'm going to put bangs on all these so you can see them as they come out. Now again, all these bangs are unnecessary. It's just a way of seeing the data as it comes out, which is useful. It's actually really useful to see data. Oftentimes what I do when I make a max patch is that I'll have a lot of values in here, a lot of objects in here to show me what's happening, but then when I'm done, I'll go in and pull them all out just because they tend to, you know, they're CPU intensive. They can slow your project down if you have numbers, boxes everywhere. So anyways, you can see now the bangs are outputting to individual outlets based on the selector, okay? And so now what I need to do is send a specific number to the piano. And I'm going to just choose a MIDI number sequence that I know sounds good because it's a series of chords or a series of notes in a scale in a chord, kind of. All right? So there's several ways of doing this. One of them is with a new object, trigger 60. All right? And what that's saying is to trigger the number 60. And you'll see that happen when 1 comes around, it's going to trigger 60. I can also make a message box that says 60. So you can see how these two things are similar, but they are different. They do the identical thing. Basically, it's triggering this number or this button, number 60, and that will trigger. I'm going to go ahead and stick with these. And I'm just going to use all of them on these objects. Now, I've found it to be easiest just to like option drag things and then change the numbers. So use objects to copy for new objects and then change all these numbers. So I'm going to do 60, then 63, then 67, then 68, then 67, then 72, 74, and 72. Okay? And, you know, I know my MIDI numbers really well. I've been doing this a long time. 60 is middle C. This is E flat. This is G above that. This is E flat or A flat right above that. And then back down to G, then up to high C, up to D, and then back to D to C again. All right. Now, if I connect all these in here, it's going to play my sequence. Okay, so you can see my MIDI numbers now are playing over and over, and this sequence is just going to play constantly as it goes. So let me turn it on here, unmute. Great. So this obviously works, and you know, remember, I mean, I think we've talked about this before, but the metronome here has an outlet on the right, yeah, an inlet on the right. And what this inlet does actually is allow me to change the tempo. So it replaces the 500 with whatever is coming in here. So I'm going to make a slider, okay? And I'm going to use this slider to allow me to change the tempo in real time if I want to. Okay, now right now the value of this slider is probably 1 to 127. I don't know. I can find out by connecting this here and then checking it. Sure enough, 0 to 127. So that isn't a great range. So the range of this is 0 to 127, and I don't necessarily want a really fast tempo. We might want to get no slower than, I don't know, 200 or something. So I'm going to use the inspector again to change the range of this object, all right? And I do that by hitting Command-I, or I can right-click on this and say Open the Inspector, and it will open it as well. Now you can see over here the range of my object is from the minimum is 0. I'm going to change this to 200. And then I'm going to change the range to 500, or well, let's put 1,000, okay? I don't need a float output, so that's good to go. And now let's see what we get from this. We get a 200 on the bottom and we get a 1,199 on the top. So if I wanted to make this, only go to 1,000, then I should change that range to 800, right? Or it might be 790, probably 799. Okay, and let's try this again. Oh, I went the wrong way. So instead of 799, it needs to be 801. Just kind of silly, but there it is. 200 to 1,000. All right. Now I can connect this here, and what's going to happen, of course, is that the 500 is going to theoretically be replaced by whatever number is coming out of this. All right. Now we won't see it change, but it is going to change. So let me turn this back on. Okay, so you can see now I have a variable speed, basically sequencer playing, right? Which is useful and interesting. Okay, so that is it for adding a sequencer. Now there's way more things you could do with this. There's actually some really cool things you can do. For instance, I could do this. Let me just, actually, let's come back to that. If I have time. I don't want to make this too long, but I might come back to adding another chord. So let's talk now about the envelope, okay? An envelope, if you might remember, we talked about this in 206 probably, and it's the way of making a sound start and end every time it's triggered, okay? What we want is for this note to play and then dissolve or go away, right? So we have an attack time, the decay time, the sustain, and the release. And we're going to use a really cool little tool here to make this happen. It's called and again, you'd think it would be called envelope, but it's not. It's called function tilde. Function, so I make N for new, function tilde. Okay? Or I guess maybe it's not function. I guess it's not function tilde. It's just function. So when I lock this down, I can actually draw an envelope in here. All right. Now I can draw like a shape like this. And technically, our attack time here is this bit, right, up to the first node. And then we don't really have a decay time. We really just have an attack, a sustain area, and then a release in this sound. All right. Now, if I go to the inspector and I click on this object, again, inspector is Command I, or I can right click and say go to inspector. If I go down to the bottom, it will tell me, if I go into the center here, it's showing me the domain of the display. The display is 1,000 milliseconds long, okay? So what that means is when this sound is triggered, it's going to map the values of all of the elements on this line over 1 second. All right, so let me show you that. If I connect a button to this and I make a line tilde. So when I attach line tilde to this function, and again, it has to come out the second outlet, not the first. That's one of my students' mistakes all the time. Second outlet is going to give me all the numbers. If I send this to a number tilde object, when I bang this, what it's going to do is show me all of the values on that line that I just made over 1 second. Okay? So we're now going to use this to make an envelope and to make our sequence play more musically. All right? So let's zoom out here a little bit. So what I want to do now is, as you can see, the values coming out of here are between 0 and 1. So I'm going to use that to my advantage. What I'm going to do is right down here where the sound outputs, okay, right before this last volume controller, And I don't know if you guys saw that, but I implemented a volume controller that collects all of the volumes and then into one volume, and it just makes it a little bit easier to turn on and off. I'm going to delete these cables, and I can select cables by holding down Option and selecting them and deleting them. And I'm going to insert a multiply tilde and then a 0 decimal object, okay? And I'm going to reconnect all of these there. So what I'm saying right now, of course, is multiply the frequency by whatever. Right now, it's multiplied by 0. So if you're smart, you can imagine what that's going to do, right? Anything times 0 is 0. So, but the right outlet of this could be replaced by something else. And what we're going to do is replace it with this line tilde, with the line. So again, I'm going to do the number tilde box. I should have taken it out. I mean, I can leave it out. I don't need it. Connect these objects. And in fact, this might not work. So let's see what happens. Actually, it should work. So what's going to happen now is every time, let me turn this off or on. Right now there's no sound because I'm multiplying all of my frequencies here by 0, right? There's a 0 here, there's a 0 here. If I bang this object, I should now hear the sound. All right, I don't hear the sound. Why is that? I think it is this number tilde. I don't want that. Let's see what this does. Now it works. Okay, so I can now make an envelope for each note. So let's do this and shorten this a bunch and watch when I hit this. Right? It's now playing the individual notes based off of this shape. So if I want to automate this, the easiest way is to connect the keyboard or any of these outputs. Actually, even the metronome up here could go straight there. Could go straight down to here. Okay? You know, I could run a big cable if I want, whatever. Let me show you one other really cool thing in Max. So I've told you everything has to be connected with a cable, and that's kind of true. There's also a really cool thing in Max called sends and receives. So if I hit new for something and it send and then any unique name I want, okay? I could use Taifa. It's one of the songs on my album. I'm going to send a value to this object called Taifa, and I'm going to receive an object called Taifa down here. And you can see, watch what happens now. So Taifa is sending and receiving data without a cord, okay? So that can be really useful for bangs and for all kinds of stuff, all right? So I'm going to do that so that I can avoid a really long cable down to my bang. So let's go over to the Metro, and I'm going to hit send Metro value. Let's do that. Okay, and I'm going to run it right out of the Metro. And then I'm going to copy this and bring it down here and connect it here. I'm going to change the S to an R for receive and connect it. There it is. So now our synthesizer is playing this value here, and I could shorten these notes if I wanted. I could lengthen them as well. So, and I could also make any shape if I put some more nodes on here. So, those are the, that basically covers everything for your assignment. And you can see that I'm basically creating more variation here. And I've turned my keyboard into a synthesizer, right? And it's now creating a synthesizer sound that's not constantly playing. So now if I turn the synthesizer off, for instance, it will go to silence because it's being controlled now by this envelope generator called function. It's a really great object, and this is just a great way of controlling data, okay? And to controlling sound is to use the envelope. I use this a lot. Anyways, that concludes this assignment, you guys. So this is your second Max assignment. And there is some variation you can do with this as well. And obviously, you can see, I want to mention too that we are following the basic principle that I talked about at the beginning of class. We're starting with a simple concept in Max and then expanding that concept, right? So the more we add to this, the more complicated it gets, the more complicated it sounds, but it still has its individual components that can mostly be taken away or changed, right? So the system is growing. It's becoming more complicated through variation and through additions and what have you. But the core components of the oscillators and the note picking, it hasn't changed. We've just now added an envelope and we've added a sequencer. On our third assignment, we're going to add reverb and delay. We might actually do that today, or I might do that. But it shows you kind of like how we do this.